Hi, this is Physics Unit 1, January 2018. Number 1. The unit for power is the watt. Which of the following is equivalent to the watt? So, the formula for power is energy by time, right? Energy is also a form of work done. So, work done equals to force into distance. So energy can be also written as work done, and work done equals to force into distance. So force into distance by time. And then force can be written as F equals to ma, since it's the Newton's first law. So mass into acceleration into distance by time. So mass, the standard international unit for mass is kg. The standard international unit for acceleration is meter per second square, and for distance it's meter, and for time it's seconds. So it would be kg meter square second cube. So the answer to this question is D. Number 2. The thickness of a steel sheet is reduced by passing it between two rollers. The thickness reduces because the steel is ductile, hard, malleable, stiff. So the property of ductile is actually, you know, when we have so this is a wire, and we are holding onto the wire by two pullers. And there is another scenario where in this scenario we are pulling the wire apart in this direction. This puller is moving in this direction, this puller is moving in this direction. So due to this is a tensile force. So due to a tensile force, it is drawn out into wires. So this is actually ductile. So the ductile is not the answer, because here we are using a compressive force. Ductile and malleable are both similar, but they have their differences when it comes to compressive force or tensile force. So the answer is not ductile. It is not hard, because hard is a property which just checks how it resists any scratch or something like that. For example, in our mobile phones we have hardness tests where we use a pin or something like that to see whether any tiny particles such as sand or something like that in our pocket might put a scratch on our screen. So this is the hardness. This is malleable. Malleable is the correct answer for this question, because malleable is a compressive force, and these two are sort of compressing the steel sheet into thinner ones. So the answer is C. Answer is not D, because object is not stiff at all. Object was stiff, then steel would not have been compressed like this. When it is coming out, it would look something like this, as thin as that we are seeing in this diagram. So the answer to number 2 is C, malleable. Number 3. Measured quantities can be either vectors or scalars. Select the row from the table that is not correct. So a scalar quantity is one that has magnitude but does not have any direction. A vector quantity is one that has both magnitude and direction. So this measurement is 21 degrees Celsius. So 21 degrees Celsius is temperature, right? So temperature is a magnitude, but temperature does not have any direction. So this is scalar. This is the correct answer. Second one is time. So time does not have any direction, right? It has a magnitude. The magnitude is 120. So a magnitude is basically any value. So it has magnitude but does not have any direction. So it is a scalar quantity. Option C. Option C says that this is acceleration. This is the unit for acceleration, minus 6.5. It is said to be a vector quantity. So it is a vector quantity because acceleration has a direction, there is another way we can prove this. We have the Newton's first law, F equals to ma. So force is a vector quantity, mass is a scalar quantity, so acceleration should be a vector quantity. There is another scenario where if we multiply two vector quantities, we will get a scalar quantity. Let's check option D. 15 joule. This is a unit for energy and it is said to be a vector quantity. So this should be a vector quantity since force equals to, no, work done equals to force into distance moved. So work done is also joules, in joules. So work done, if work done is equals to force into distance, force is a vector quantity as displayed here, and this distance is also a vector quantity because it is the distance moved from the force. So this is also a vector quantity, and as we know that vector into vector equals to scalar, so work done is actually a scalar quantity. So the answer to this question is D, since this is not the correct answer. Number 4. A projectile is launched at an angle theta to the horizontal and takes time t to reach its maximum height. Which of the following equation can be used to determine the initial velocity u of the projectile? So we have, this is a Suvat equation S U V A T, where S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is time. So we have projectile being launched at an angle theta upwards and it takes time t to reach its maximum height and the initial velocity is u. So this would be, this component, the vertical component of the velocity would be u sine theta, and since this is u sine theta, initial velocity will be u sine theta, and it says that it takes a time t to reach its maximum height. So it in its maximum height, the final velocity would be 0, and since it is going upwards and it is in Earth's gravity, the acceleration will be downwards. Since it is moving upwards, there will be a force due to the gravity in the downward direction. So instead of g, since it is upwards, it will be minus g, for downwards it will be g. So the acceleration is minus g and the time is t. So using these four, we have the equation which is v equals to u plus at. V is 0, u is u sine theta, a is g minus g, and the t is time t. So we need to make u the subject. U sine theta equals to gt. So u equals to gt by sine theta. So gt by sine theta, so this matches with C. So the answer to this question is C. Number 5. The flow of a fluid through a pipe is laminar. Which of the following statements correctly describes the velocity of the fluid? So let me draw a pipe. So let's assume this is a pipe, and through this pipe water is flowing like this. These are the layers of water. So this is a layer, these are also layers, so these individuals are the layers. So in a laminar flow, it flows like this with constant layers, and in a turbulent flow it is like this. The flow is always disruptive, it is not, there are no adjacent lines. So in a laminar flow, these adjacent layers have different velocities, and in this particular adjacent layer the velocity is same. In this layer the velocity is same, in this layer the velocity is same, but between the two layers there are differences in velocities, and the pipe has a surface like this, so these layers have a lower speed because there are friction between the water layer and the pipe. So the maximum speed might be in the central area, not where the pipe is near to the water. So part A, at a particular position the velocity is constant. Yes, this is true because at a particular position it will always be in one layer of the flow. So in this particular flow of layer at this particular point, and in this particular layer the velocity will always be constant. So the answer is A. Part B shows that at a particular position the velocity is continually changing. So this is just opposing answer A. Answer C says that the velocity is a maximum at the edges of the pipe. So it is not true because there are friction between this layer and the pipe. And option D says that the velocity is always the same in adjacent layers. It will never be the same in adjacent layers because for example this layer has less friction than this layer, so of course this layer will have a greater speed than the other layer which is experiencing larger friction. So the answer to this question is A. Number 6. A solid cylinder of diameter 0.025 meter is placed on a table. A force is applied to the cylinder as shown. So this is the table, and this is the force of 15 Newton, and this is the cylinder. So the cylinder is being placed on this table. The stress in the cylinder in pascals can be calculated using, so this stress in the syllabus, stress is equals to force by area. So the force is 15 newtons, right? So the force is 15 newtons, and the area, we have the diameter but not the area. So from the syllabus from O levels mathematics B, the area of this, the cross sectional area, is pi into r squared, and we do not have the radius but we have the diameter, and the diameter is 0.025. So the diameter is actually 2r. It is because since when we have a circle, if this is radius r, this would be diameter, this is d, and d is equals to 2r. So 2r equals to 0.025. So the radius would be 0.025 by 2. So it would be pi into 0.025 by 2 squared, which is pi into 0.025 square by 4. So the area would be, this is the area is pi into 0.025 by 4, which is 15 into 4 divided by pi into 0.025. So the answer to this question is C, since this exactly matches with this. Yes, so a small error in copying, so this square will come here and here. So the answer to this question is C. Number 7. A box of mass M is pulled along the floor by a horizontal rope. The tension in the rope is T. So the tension T is here. The box moves from rest with an average acceleration A. Which of the following is the correct expression for the frictional force F acting on the box? So it is being accelerated by acceleration A with a tension. There is a tension and there is also an acceleration, and there is a frictional force. So if we draw a free body force diagram, it would look something like this. This is the reaction R, this is mg. So there is no vertical acceleration since r is equals to mg. So these two cancel out. So since these two cancel out, the answer won't be c or d, it is a or b. So if we consider the horizontal components, we will get tension here and friction in the left direction. And there is another term which is resultant force. Since F equals to ma, so the resultant force will be the balancing force for this. So the resultant force, the force resultant, is equals to tension minus friction. The force resultant is F equals to ma. So ma equals to t minus f. So if we make f the subject, minus f equals to ma minus t. So f will be equals to t minus ma. So this matches with option B. So this is the answer. So this is number 8. A student carried out an experiment to determine the Young modulus of a material in the form of a wire. The original length and the diameter of the wire were measured. So this is the original length and this is the diameter. Diameter of the wires were measured. A load was applied to the wire and the corresponding extended length was measured. Which of the following combination of original length and diameter would produce the greatest extension? So the formula of Young modulus is stress by strain. So stress is force by area and strain is extension by original length. So when the original length is long, there will always be a higher extension. For example, if we have a rubber like this and a rubber like this, and when we apply the same load, for example 10 Newton load here, if we apply 10 Newton here and 10 Newton here, this might have an extension of 2 meter and this might have an extension of 5 meter. So the extension of the longer original material will always be higher than the shorter original material. So the answer would be either A or B. And the diameter, so a larger diameter for a larger diameter, there will be a larger cross sectional area, and for a larger cross sectional area for a fixed force there will be lower stress, and since there is a lower stress there will be a lower strain, and since there is a lower strain the extension would be lower. So the answer would not be A, since it would not give the maximum possible extended length. So this is the greatest extended length, which is not given by option A. So option B would give the highest extended length since it has a smaller diameter. So with a smaller diameter, what we will have is, for a smaller diameter there will be smaller area, so higher stress, higher strain, so there will be a higher extension for a given original length. So the answer for this question is B. Number 9. The diameter of a wire was measured using micrometer and found to be 0.35 millimeter. The micrometer reads to the nearest 0.01 millimeter. Which of the following is the most appropriate percentage uncertainty to use with this measurement? So the percentage uncertainty formula is the uncertainty of the equipment divided by the measurement 200. So the calculated value would be 0.01 divided by 0.35 into 100, which gives 2.8%. so 2.8, it's 2.85, so this would have been 2.9%, but this will be 3% since the micrometer reading is to one significant figure. This could have been two decimal places, but when we are dealing with uncertainty, we will always use significant figures instead of the decimal places. So since it has one decimal place, it will be 3%. So the answer to this question is C. Number 10. A mass is fixed to one end of a meter rule which is pivoted on the other end. The mass and meter rule are held horizontally and released as shown in the first diagram. So this is the mass and this is the meter rule, and the meter rule is connected to this pivot. So and the meter rule are held horizontally and released as shown in the first diagram. The mass moves to its final position as shown in the second diagram. So the mass, when this is released, it goes in this direction. So this, we can label it as scenario A. This might be scenario B. This is the mass. This might be scenario C, scenario B, C. This might be scenario D, and this is scenario E. So in scenario A, the vertical displacement is 0. So since the vertical displacement is 0, but this is the maximum which the mass can travel downwards. So this is actually the gravitational potential energy mgh. So when the vertical displacement is 0, the mgh is maximum. So if we plot a graph, it will look like this. So this is E grav and this is vertical displacement. Say when the vertical displacement is 0 at point A, the E grav is maximum. When it is at point B, the mass is at this level. So this is the vertical displacement, and this length is the E grav. So as the vertical displacement is increasing, the E grav is decreasing from this E grav to this E grav. This E grav is smaller than this E grav. So at a higher vertical displacement, the E grav is lower. At point C, at this point C, the E grav is 0, but the vertical displacement, so this is the vertical displacement at C. So at C, the vertical displacement is maximum. So at C, it is maximum. It is here. So the graph might look like this. So when we are going back here, so this graph is basically till point C. So at this point, point E, the vertical displacement is this vertical displacement, and the gravitational potential energy is this E grav. So again, from point D, from this point to this point, the graph replots itself. So the answer to this question is B, since if we draw the graph from point A, B, C, it goes like this: point A, B, C, and is here and D is here. So point A, B, C, D, point A, B, C, D, it goes up to the x-axis, it touches the x-axis, and then from here to here, the graph just replots itself going upwards. As the vertical displacement starts decreasing, the E grav starts increasing. So the answer to this question is B.